Hi everyone, it's Orkan. Today we have a problem when we are given k linked lists and each list is sorted in ascending order. So we need to merge all linked lists into one sorted linked list and return the result. So also, for example, we are given example 1, we have 1, 4, 5 and we have 1, 3, 4, 2, 6, and we are merging this three list into a single list and returning it. We are going to solve this problem using a minimum heap. So let's remind ourselves, what is a minimum heap? Minimum heap is a binary tree that guarantees that in the root we are going to have a minimum number, minimum element. So for example, in this case, we have three lists, list 1, list 2, and the list 3, and we are adding the value of first node to our minimum heap. So we are adding 1, 1, and the 2 to the minimum heap. And also besides that, we are creating a result where we are going to add our nodes, our sorted nodes, merged nodes. So first, let's pick the element from the root of our minimum heap, our binary tree, and we are taking 1, right? Since the list 1, it's an element of the list 1. Since the list 1 has next element, so we are moving to the next node and adding that to our minimum heap. The same operation we are performing again. So we are taking from the root the element and adding that to our result. And since the list 2 has the next element, we are adding 3 to our minimum heap. Now again, we are taking 2 from our minimum heap and moving to the moving and adding 6 to our minimum heap. Again, we are doing the same with the 3, adding that to our minimum heap, and so on and so forth. So at the end, when we are running out of the all elements, so when we have added all elements to our minimum heap and we don't have any element in our minimum heap, we have a merged, so we have a list, we have a result where we have merged all elements in sorted order. So we have, for example, in this case, list 1, list 2, and the list 3, we have sorted to our result. What is time complexity in this case? The time complexity is n multiplied by log k. Log k is the insertion and the deletion operation to minimum heap. We are going to implement that in Java. In Java, the implementation of minimum heap is a priority queue, and the operation cost is the log of k, so adding and removing the element. Also, the n is the number of the all nodes in the list. So let's say that the list 1 has 5 nodes, list 2 has the 10 nodes, and the list 3 have the 15 nodes. So the n in that case is equals to 30, all nodes. And also for the space complexity is determined by the size of the minimum heap, and at the most it will contain O of k of elements. K is the number of the linked lists. Okay, first thing that what we do, we are checking two corner cases. If the lists are equal to null, and if our input doesn't have any list node, then in that case we are returning null. The next one is that we are initializing our minimum heap. In our case, in Java, the implementation of a minimum heap is a priority queue. So we are comparing by the values, a value minus b value, so it will give us it's the implementation of the minimum heap in Java. So the next one is that we are going over our linked lists and we are adding that to, if it's not equal to null, right, if there is a nodes, then we are adding that to our minimum heap. The next step is we are initializing our result. We are setting the value to 0 by default, but we can set to any value. Then we are not to lose the head, we are creating one more node, current, that is pointing to our result, and then we are going over and until our heap is empty, we are adding the result to our result node. So we are taking from the minimum heap, we are taking the element which is the minimum, so we are current next, it will point, so we are adding that to our result, and then we are moving our result to the next node. And if the minimum next, if there is another node, if there is still nodes remaining in that linked list, we are adding that to our minimum. We are adding that to our minimum heap. And at the end, so we are the result, we are returning result next, which will point to our first node. Okay, that's it. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.